And then
there's sound coming out of this.
You're talking into it, it'll pick up.
Okay, cool. No, I mean, okay, so now the microphone's working. I can go and get started. Good evening. Hi. So, how many of you guys were here at campus? No, not campus. Wherever it was for Julie Ralph's talk a couple of weeks ago. She talked about Protractor. She went into a lot of detail. Okay, so this is kind of positioned as a little bit of a continuation on from that. So when she was talking about Protractor, we were kind of like, yeah, that's cool. Protractor's awesome. But actually, we started applying acceptance testing and BDD to testing our Angular apps, and that sort of came up in conversations during the evening. So there were a couple of people who were like, oh, this sounds kind of cool. Cucumber, we're using Cucumber.js. So we decided it would be an interesting thing to do to have a follow-up section to delve into a bit more detail about that. So that's what I'm going to talk about tonight. Hashtag is AngularJS London, and you can follow us at WongaTech. That's our Twitter account where we talk about some of these events and some of the other content, some of the stuff we're open sourcing. So, without further ado, let me get started. So what am I going to talk about tonight? I'm going to give you an explanation of what acceptance testing and BDD are. So BDD has been around for about getting on towards 10 years now. And I personally had an experience of I kind of seen it and I'm kind of familiar with it. And I thought it was kind of interesting, but never actually used it that much. And I never actually used it in anger. And I kind of realized actually whilst putting this talk together, that there's a lot of detail in there, a lot of good stuff that I didn't know about. So I'm going to talk about some of that stuff. Then I'm going to talk a little bit about how Cucumber.js and Protractor work together, so how you can use acceptance testing and BDD in an Angular context. And then I'll give you some sort of tips and tricks and patterns and ideas of how we're doing that and how you might want to do that in your applications. And you're free to disagree with me on any of those. Some of them are a bit controversial, so by all means, give me some feedback. So, what is acceptance testing? I talked about, I did a run through of this talk earlier today and had a few questions from some of the developers here at the end of it. And one of them was related to acceptance testing in a very specific context. And so, like, we're doing it this way in our team, we're doing it that way in our team. And I had the idea, actually, there's a maturity model of acceptance testing. And I didn't have time to make a slide out of it, so I'm just going to gesticulate. So the first kind of point for acceptance testing is having conversations. It's talking to other people in your team, and it's having a sort of language to express that. So wouldn't it be great if you had a scenario like this, where you went and spoke to your product owner and said, oh yeah, I need to know a little bit more about the login situation. And they said, well, actually, I'm going to give you more information about the login scenario, and I'm going to do that in a language which is really clear and concise and precise, easy to understand. We all agree, we all kind of get it. And this is a sort of very contrived example. So, you know, this is what happens in the happy path. But actually, acceptance testing gives you a language where you can talk about edge cases and all the different outcomes that you expect in your app as you're sort of working them out. And where does it come from? So it comes from BDD, and BDD is this sort of improvement on TDD. So there's this guy called Dan North. He was doing TDD. He's done XP, and he's been working with Kent Beck and all these cool guys. And he had a few questions. So he wrote this introduction to BDD, and he said, programmers want to know where to start, what to test, what not to test, how much to test in one go, what to call a test, and how to understand why a test fails. So he had all these kind of questions. He was doing TDD, and he said, well, actually, you know, I think that I'm coming up against these questions again and again. Why isn't there a form of testing that actually makes some of these questions easier to answer or go away? And so what he did was he kind of formulated BDD, and he said, well, actually, I think what's interesting is we're talking about the behavior of an app. We're talking about what it should do. If we put emphasis on what it should do rather than what it will do, then maybe that means we can look at these test criteria, we can read them, we can agree them together, and maybe actually we can say, well, hang on, should it do that? Maybe it shouldn't. Maybe, you know, ask those questions. It gives you an idea of where to start, because you start with the first thing it should do, right? It's like, well, the most valuable feature we could add to our application right now is X. So let's write a test. It should do X. Given no previous setup, when I interact with it, it should do X. So it starts to give you some of these tools, and I recommend that you go and read his original introducing post. I'll put these slides up at the end, and the link's in here, and it's at the right at the end of the deck as well, because there's a lot of detail, and it gives you a history of kind of how he was thinking about acceptance testing. The bit that it's really famous for is the idea that your criteria, your acceptance criteria, can be discussed amongst your team, and that can use a very specific set format, and that format can then be translated into something that's executable. So you probably may have encountered this somewhere. This is like the most kind of famous single takeaway from BDD, given when then. Given I am in some world, so I'm a user who can delete a post, I'm a user who has previously signed up, there's lots of different examples. When some event occurs, like a schedule activity happens, or I click something, or I open the app for the first time, then some outcome should occur. If you've been doing unit testing, you may have come across arrange, act, assert, get that right? And that's a kind of way of organizing your unit tests. Given when then is just kind of doing the same thing. It's breaking up your test into some chunks that are easily manageable, and that's really just a kind of special case of input, processing, output. So it's good old-fashioned computer science, good old-fashioned functions. Where BDD kind of really starts to get interesting. So let's come back to our maturity model. That having conversations around your tests is kind of the first part, and you want to be doing that on a regular basis. And then when you're doing that on a regular basis, then you can start to say, well, hang on, if we've got these acceptance criteria, let's start to use some tools to make this form of testing easier and to make it executable. So we've got the same criteria mapping into the tests, mapping into our actual code. And Cucumber.js is a tool that lets you do that. So Cucumber, so when Dan North started writing about BDD, he wrote a tool called JBehave, and then that got superseded by a tool called Cucumber, which was implemented originally in Ruby. And now Cucumber is available in every language under the sun, and there's different implementations. There's like 5 for Python and that kind of stuff. Cucumber.js is the JavaScript version, and is especially suited to JavaScript apps, and there's some nice things that it can do that we'll talk about later. But essentially, it's a really, really simple tool that lets you translate this kind of human-readable specification into a bit of code that you can execute. And there's no kind of magic to it. Actually, it's really cool. You can just put anything in this space here. So whatever your criteria are, you can go, and Cucumber.js runs as a Node.js executable or program. So any API you can get your hands on, you can use to implement steps. So you'll see there's the kind of common language, so given and this.given. You have this piece of text which matches into the actual scenario text, and then you have a callback function. And then after that, you're kind of free to do whatever you want. So it's actually deceptively simple. How does it work? So when you're actually programming Cucumber.js, you're building tests with it, what you will do is you will write feature files. And so these are the criteria that we talked about, that we saw earlier. So a couple more contrived examples. Each of these sets of criteria will get grouped into a scenario, and a scenario is basically some outcome that you want to achieve. So my app needs to be able to do a couple of different things, so we've got a couple of different scenarios. Those are then grouped also into features, and features will be the kind of large-grained, coarse-grained parts of your application. So login, search, dashboard, the major kind of pieces of your code. So feature files are a way to take your scenarios, just put them in a file, keep them somewhere where everyone can see them. You're encouraged to keep them, as I say, somewhere where literally everyone can see them. So a kind of anti-pattern is putting them in Git or SVN or whatever, and sort of that kind of belongs to the programmers, and the programmers edit them, and they're sort of the guardians of them. What you're really trying to do is make them a shared document, and a lot of the patterns that I'll talk about later on are actually about, well, you know what, we want to make sure that everybody can edit these, everybody can read them, everybody can write them. So don't hide them too well. Step definitions just live in JavaScript files, and you can have lots of them, you can reuse them. As I said earlier, they can do anything that can be automated. Excuse me. Here I just have a step definition which uses the Protractor API, and there's a nice integration between Protractor and Cucumber that lets you do any of the kind of Protractor things that you may have seen already in a Cucumber step definition without any setup at all. So in Cucumber, you can set up a world, which is kind of the macro context that the test runner set up. We didn't actually have to write any of that at all when we wrote our Cucumber tests. So browser is the common object that you'll see a lot of. There's also elements and all the other kind of bits of the Protractor API. Step definition could do anything. So we could just create some values. We could call out to some other object, sort of a mock factory if we had such a thing that was creating user objects. Or we could run a Jenkins job and then go and get the data from that and put that data in a user object. That's, you know, a pretty chunky step definition, but you could use some example of some idea of the complexity of what you can do. Little note, one of the things that's interesting about Cucumber.js as opposed to other Cucumber implementations is because it's implemented in JavaScript, you have to deal with asynchronicity. And you'll see this pattern in the examples that I'm going to give later. Cucumber will pass you a callback, and when you're done, you implement that callback, so you call that. So it's the same pattern as you might have seen in Mocha and other testing libraries. It smells a bit when you're dealing with promises, and they have better promise support coming in the next version. But because Cucumber is asynchronous, it means that you can handle network operations, it means you can handle browser interactions in a way that can be quite fluent when you get the kind of idioms down. So let's look at a full example. So I mentioned earlier this example of a really basic scenario. Given I'm on the login page, when I log in, then I should be logged in. It's pretty free of detail in the criteria itself, and that's pretty much intentional. We've actually hidden all of the detail here in the step definitions. So again, this is using the Protractor API. First of all, I'm going to get my page. So I'm on the login page, translates to browser.get #login. Good old Angular lets us jump into a particular page. Then I'm going to interact with the page. So I'm going to get the email form field, and I'm going to send it some keys. So I'm going to send it my username. Then when that's completed, so this is a chain of promises. Then when that's completed, I'm going to get the password field, do the same thing, send it some keys. So I'm filling in the form as I go. And finally, I'm going to click the button. You know, we're assuming there's only one button on the page. And when we're all done, we're going to tell Cucumber.js that this step is finished, and it can proceed on to the next one. And then the next one, just there's a bug in this code, and I failed to fix it. Then I should be not on the login page, so this should be a not equals. But we're just going to get the URL from Protractor and make an insertion method. So this is a slightly chunky piece of code. I'm not very proud of it. It's really noisy. It's quite hard to read. There's a lot of promise-based stuff that's kind of noisy, and there's a little bit of duplication as well. I've used it on a couple of places. But more than that, it's fragile. So if the page changes, this test is going to need to be updated. It's not very robust in the face of a changing web application. So one of the things we've found really powerful is page objects. And page objects are a pattern that can help you deal with this kind of complex step definitions. So Martin Fowler, no talk is complete without a Martin Fowler slide. So I wanted to define what page objects were, and I went and read his wiki page and he had a really great definition. So I'm just going to go over what he said. When you write tests against a web page, you need to refer to elements within that web page in order to click links to determine what's displayed. However, if you write tests that manipulate the HTML elements directly, your test will be brittle to changes in the UI. So it's exactly the problem we're talking about in our step definitions before. A page object wraps an HTML page or fragment with an application-specific API. And that's the key word. It's an API for your page. So where you previously might have had a complex bunch of HTML, all this stuff you've got to do, and it's all tightly coupled to the exact CSS structure and da-da-da. Wouldn't it be nice if you could just actually have a really simple API? And one way that we could implement that is this. So this is an example of using a page object. We've got a couple of really basic methods. We're going to instantiate one. Actually, we're going to have a get method so we can load the page. Then we log in. This login function just takes really simple values. So it takes strings. It returns, if it has errors, it returns a Boolean. it's taking all that complexity of what's going on in your page and wrapping it behind a really simple API. One of the things that I like to do in Cucumber test is to do this page.get. It's actually kind of considered a bit of an anti-pattern by the page object community. So if you look at Google's documentation and some of the Selenium guys, they're really into page objects, but they say you should always get your page as part of the constructor of a page object. That doesn't for me, that doesn't map quite so well to how Cucumber works. I want to use my page object in all of my step definitions, which means I need to instantiate it a bunch of times. And if it keeps getting the page each time I'm instantiating it, then that's not really going to work out so well. So let's have a look at that implementation of that page object. So this is the page that we're talking about. It's a very simple login page. And this is the code. And we can see how the things, the parts of the code map across. So we have a couple of different elements that we've pulled out of the page. Again, just using the CSS, but we've hidden that behind this object. This object now completely owns all of the details of the page structure. So we have email LM maps to this email field here. So if I turn these off again, you can see email, password, login, and then email LM, password LM, submit LM. These are actually just private, so they exist, but we don't expose them. We don't let other parts of the code use those. We expose a simple API with a couple of functions, get, login, headers. And all these functions are doing are calling the same code that we called before. So they're the bits that are responsible for actually calling back to Protractor. Again, so that needs to be threaded. That doesn't contain all the parts of the promise logic that it needs to. This does, and so it's a little bit of a chewier implementation. But you can see how it's abstracting away the complexity to some extent. So okay, it returns a promise, but that promise will evaluate a simple Boolean value rather than a complex page object or a node, for example, an element. Part of the nice thing about this is that then our step definitions become pretty trivial. So if we then re-implement our step definitions, they actually have very small amounts of code that's actually doing the work. So when I was putting this example together, I was like, I really must be able to delete more code from this. You know, it's still way too long, way too complicated. Unfortunately, at the moment, you can't do that because you still have to have this evaluation of the done callback in every single step. As I say, that's going away in the next version of Cucumber, so it should be a slightly nicer expression. So I'm on the login page, maps to login page.get. I log in, maps to login page.login. And then I should be logged in, maps to do we have any errors? And then we're using a chai as promised assertion here to see that this has everything resolved to false in the final analysis. Now, you don't have to use chai. It makes this a little bit more readable, but there are other ways that you could have done that assertion. So that's pretty much it. That's how kind of simple and effective Cucumber can be. Actually, it kind of doesn't give you a huge complicated library of stuff. It just gives you a kind of quite a simple pattern and implements it. So what I'm going to do now is talk about some of the patterns that we found are useful when we've been developing apps and when we've been acceptance testing them. So the first thing I would say is keep them really high level. So there's a real temptation to go into kind of the minutiae as a developer sees it. So when we write unit tests, we may think about things in terms of, I've used this arbitrary example of like a permission ID. Like this user's got permission 55, right? So you should be able to do that. As long as they've got that permission, they should be able to delete posts. What we actually care about is the fact that they can delete posts, or they can do advanced level searching, or they can run twice as many queries per second as everybody else, or whatever. There's some aspect of the behavior that we're really trying to capture. And in our acceptance criteria, we want to express that behavior. So here at Wonga, we talk about people being able to extend or people being able to borrow. You know, we don't really care if they want to borrow £1 million. What we care about is they want to borrow an amount of money that's out of the range that we'll lend them. So that's what actually you want to have a conversation about. So I think that one of the things that you will see quite a lot is this idea that when your application changes, if certainly your implementation is changing, then your test shouldn't necessarily have to change as well. So if your criteria are kind of written at a sufficiently high level, then actually they're robust to some of the implementation changes. And that's a good example of that. So you can then take those, so permission 55, you still need to know about it at some level in your testing, perhaps, but it can be abstracted away into the step definition. And that makes the executable code and the criteria each kind of have a clear responsibility within the framework. Don't use the UI to set up state. So if you wanted to create a new user, you might be tempted to say, well, okay, we'll go to the registration form, browser.get hash registration, we will fill in the form, we'll type some keys, we'll press some buttons, and then eventually we'll get to a user that's in a particular state. Well, what happens if you do that is you end up with a really slow, fragile test. So WebDriver will be flashing away on the screen in the corner, and every now and again it will break because the machine's under too much load, or it's going across the network to source labs and you'll get a partition, and these things just are a little bit unstable. So you can neatly shortcut that by building yourself some simple factories. So let's just have a little factory that creates a user and puts it in a certain state. We use an awful lot of mock data, and I'll come back to how we use mock data a little bit later. Cucumber.js and a lot of the Cucumber implementations have some really neat features that you're that I, as a developer, have been tempted to use. One of those is the ability to pull out parameters. So I could take this and feed them into my step definition as arguments. And then maybe I could write a whole bunch of other tests that use those, but I've tested with Ben with an invalid input and password with like too short, too long, two different variations. But actually that isn't capturing the behavior we want to talk about. It's capturing, again, the kind of technical implementation details. A nicer way to abstract that is to say, when I log in with valid credentials, when I log in with invalid credentials, when I log in with an expired account, capture what it is that's really important to you, keep it high level, and your test will live longer and be more robust in the face of change. Caveat, this is really all about a conversation with the whole team. And one of the reasons why you want to keep it simple is often because you're wanting to include your product owner and your business team in those conversations. If you have a team, if you're working with a team of people who are all pretty tech savvy, then okay, maybe this is a useful feature. Maybe it will actually make expressing some kinds of tests more efficient and clearer. There's another feature called tables, where you can literally include a big table of this, then, that, whatever arbitrary tabular data you want to feed into a test. Again, I think if you have product owners who are comfortable with that, then that might be something you want to try using. For me, I've sort of used it, and I've kind of gone, that's a really illegible test. That's a really difficult to read test. I think I'll refactor that a little bit. There is a bit of a distinction here between tests that are business writable and business readable. If I were to omit these quotes, this test would break. The Cucumber engine wouldn't pick these up as being parameters, and it wouldn't feed them into the call, but the step definition, and the test wouldn't work properly. So that makes it a little bit difficult for somebody who's not technical to write a test. But they can still understand what's going on here. They can quite often still read it and say, oh, okay, I can get a sense of that. And that means you can still take the conversation, so your job is kind of done at that point. In summary, your mileage may vary. It's down to your team. You can kind of make your own decisions. I would say that one of the downsides to sort of this approach is sometimes you'll end up with a lot more step definitions. So you might end up with quite a lot of small kind of boilerplate step definitions to do lots of different things. If they become unmaintainable, that's a pain point, that's a problem. If they are reasonably straightforward to maintain, then that's okay. And one of the things you could do is implement a factory, actually, to make new step definitions. So you can actually use higher order programming to make that a little bit more manageable. This one's my favorite one because it's the most contentious. Never say click. So if you're saying click, essentially what you're doing is you're binding tightly to your UI implementation. In this example, let's imagine that we have a form and it has a drop-down list. When I select summary from the report type drop-down, what happens when we turn that into radio buttons? Our test is going to break. The nice thing about this is actually we could have one step definition that can interact with all of our drop-downs, and we've implemented some patterns like this in our acceptance testing code base. And now I'm feeling a bit sheepish because actually I think these are a bit brittle, and what I really wanted is a set of tests, a set of features that live on even when we have decided to change the exact expression. When the UX team have come by and said, hey, you know what, we've got this great new idea for how we're going to do this screen, we're still capturing the same behavior, right? We're still interacting with the customer in the same way. So actually, we want a test that's a little bit more robust. So when I choose a summary report type is a nicer way of expressing that. We pull the logic down into the step definition, and then we deal with that, those technical details in the developer side of things. The sort of inverse of that is you want to be able to reuse steps. You will end up with a lot of step definitions if you start writing a lot of acceptance criteria. And you hope that a lot of them will be simple, but if they're so simple that you're kind of just writing out boilerplate steps, it would be nice to reuse them. When you do that, you want to think about how you're doing it. This step definition has this fantastically complicated regular expressions, which actually means that the text that it matches is quite flexible. So what I can do here is I can say something along the lines of, when I change some value, when I change date of birth to so number of units, so 30 years from now, so maybe let's say next payday, so I can change next payday to 30 days from today. That's we've kind of implemented a new programming language here in our step definition. It's a very simple one, but it's going to fall foul. We're going to fall foul of that conversation with our product team. They're going to be like, hang on a minute, how do I use the from today function again? We're going to say, oh no, it's fine, it's just easy, we just do it like this. Actually, we're not really capturing something they understand, and therefore we're going to miss out on opportunities to get kind of good feedback from them about exactly whether we've done it right or wrong. So I don't have all the answers on this one, but I think one of the ways you can reuse steps is just to reuse callbacks. So actually, there's some callback implementation that maybe maps to a couple of different step definitions. You've got a really simple way of reusing steps there. I think there are probably a few other kind of good patterns, and I'd be interested to see if anyone else has got any ideas. We'll talk about that after the main talk. One of the things to be aware of with Cucumber.js is if you have duplicate steps that match a piece of acceptance criteria, it will just sort of quietly use the first one. So sometimes you can have a couple of step definitions that come into play, and you can have a little bit of a hard time working out exactly which one is getting run. The Ruby version throws an exception if that's the case, and the newer versions of Cucumber.js are going to do that soon. That just makes tracking down errors a little bit easier. One of the other things we've done is to group sort of bits of our acceptance criteria by the application domain. So I mentioned login, we have a dashboard, we have search, we have a couple of other things. Those are the kind of sort of levels that you want to group your features around. So a bad way to do things would be to kind of try and enumerate all of the scenarios a certain role might undertake. So all the things that potentially an unauthenticated user could do, because that's just going to get too large, right? If you break your application down into the different modules or different components, that's going to be much more manageable. You can reason about the different scenarios, the different outcomes that you're expecting in a much easier way. So, for example, group all your dashboard tests together. Another way to make the test more readable is to stop once you've hit an assertion. So one of the things we started doing early on when we first started writing protractor tests was to we wrote sort of kind of plain vanilla end-to-end tests. An end-to-end test, you're testing a whole journey, you're testing a flow. You might interact with 3, 4, 5, maybe even more pages. You're doing lots of actions, and that's kind of the natural state of end-to-end tests. And we ended up with some pretty chunky, like 50, 60 line tests, doing all these kind of things. We thought they were pretty great at the time, and then we actually started finding that it was really hard to debug when they broke, because they'd run off on Jenkins, and we'd get an error message, and it would say, test failed. And it was like, okay, but which of the 20 pages that it touched were the ones that failed? And actually, when we started doing acceptance testing, we knew that we didn't want to do that. We didn't want to repeat that mistake. We wanted to break things down into neat chunks. And Angular is really great for this. So you can jump into any page in your application just by specifying the URL. We have a whole library for generating mock data. So that means I can jump into a particular page, and I've got the right context there, and that page will render it as an independent chunk. And then that means I can test it as an independent chunk as well. So this code example, even is long enough that it fell off the page. How this maps back is, well, I don't want to say, when I do this, and I do that, and I do the other, then I click on this button, and it submits that page, and then I fill in that form, and then I submit the next page, and then da-da-da, because that's just going to get completely illegible and unreadable, and it's going to be very difficult to reason about, what, is it doing the right thing? What is the right thing? So what we've done is to break things down into individual pages, and this is a kind of trite example, but it means it's much easier for us to say, well, hang on, let's think about the slider page. It's just, there's a simple interaction going on here, but there's a bunch of edge cases. Let's make sure we enumerate all of those edge cases, catch all the different things that a user might expect to see and happen, and then we can say, sure, we've got that covered, and then we move on to testing another page in the same level of detail in isolation. One of the nice things in our application was we have this kind of one-to-one mapping between a page and some piece of data. So, a page will be editing some model. It's the kind of controller model mapping that's really common and popular in Angular applications. So it means that we've got this nice kind of well-contained page to start with, and then we can test it in a nice constrained way as well. I already mentioned Chai. It's a great library for doing assertions. Jasmine, on the end-to-end side of things, gives you a bunch of assertion tools, so you'll be used to kind of going, oh, I'll do this expectation. Cucumber.js doesn't give you that. In the same way as Mocha, it's just a test runner. So Chai is a nice library you can get off the shelf. It gives you a whole bunch of assertions, some of which are promise-friendly, and that means you don't have to re-implement your own. Proceeding on the kind of Angular-specific stuff, Elements in Protractor doesn't actually do any evaluation of the page. So when you create an element, it's sort of just actually creating a kind of element finder or an element detector. So that means you can reuse them. So actually, you don't want to put them in your step implementations. You want to put them somewhere else. I've already mentioned that page objects are a good place to put them as well. So those are some of the patterns that we've used and some of the ways that we've tried to make kind of Cucumber and acceptance testing a bit Angular and be a bit more manageable. I'll give you a final note by talking about how we fit this into our kind of overall development structure. So hopefully a lot of you are familiar with the test pyramid. We have a couple of different types of tests. We have lots and lots of unit tests. We have slightly fewer service tests, and that's where we do our acceptance testing. And then we have some UI tests, which actually I tend to put integration in this top part of this pyramid. So acceptance tests are not integration tests. You can use Cucumber to run integration tests for you, but the sheer weight of all the different cases and criteria, outcomes that you're going to be interested in, means that if you are integrating with lots of systems and you need to generate users and generate mock data and interact with that system and it's backed by a real database, real web server, whatever, if you try and enumerate through all those combinations, it's just going to be really unstable and it's just going to be a really slow, long-running test suite. And a test suite that's unstable and takes too long is not a very useful thing. So you can move your acceptance testing down to the service testing level, and that's what we've done. So we back it by mock data. So in our pipeline, we will build our application, which is the run JS hint, do some minification, do all the kind of usual steps. Then we'll run our unit tests. We have about 1,000 of those right now. We're actually working on a kind of reasonably new code base, so we're still growing that unit test suite. Those run really, really fast, and they never fail. Like if we fail a unit test, it's a really bad day. And so unit tests will use mocks. So we're testing just a single class, and we'll use mocks of the various services. Pretty straightforward stuff in the Angular world. On the acceptance front, we use mock data, which is injected using $HTTP backend. So we've got our own wrapper around that. We've got lots and lots of mock data. That enables us to drive through every single screen in the application and look at every kind of permutation of different user cases. One of the things we're trying to deliver sort of in this quarter is going to be running all of our acceptance tests on devices and on a wide range of devices. So we're working on a mobile app. We really want to see how it looks on an iPad, on iOS 8, on an iPhone 6, on all the different permutations. We want to make sure that the layout's all there. Because we've got all these acceptance tests that test all the different permutations, we just run that suite on each of the different devices we're interested in, take screenshots as we go, and then do the management of those screenshots after the fact, we'll be able to look at the whole application and see how it behaves in all those different contexts. Now, we wouldn't be able to do that without mock data. If we had a real system behind that, a real back end, that test suite would take like 48 hours to run and it would crash every single time. To be a bit of a nightmare. Anyway, so acceptance testing sits here. When those have all passed, then we go and do our integration tests. And for us, integration means the front end talking to an API. It doesn't necessarily mean that API is talking to all of the back-end systems and all the databases. We tend to just integration test subsets of components, because we found if we integration test kind of too big a range of things, it's just really crashy and flaky and shit. And that brings us to our journey's end. So what have I told you? I've told you that acceptance tests are conversations. So the first step on that maturity model is starting to use the given, when, then language and starting to talk to your team and saying, well, hang on a minute, have we got all of the outcomes? Have we captured all the behavior in this piece of functionality? Or is there something else? And if we can capture it now, maybe we can save ourselves the pain of having to build something twice because we did it wrong the first time. BDD builds on that by giving you a common language, and then there are some tools, and Cucumber is one of those, that lets you translate those criteria into executable code. So you've got this nice tie-in between what your test says and what your test does, and you can make sure the two are always in sync. You can call anything from your steps, and Protractor is a really powerful API for making nice automated tests of Angular applications. Page objects take away some of the details of your pages and hide them behind that nice API that I showed you, nice friendly API. And I mentioned that we use mocks for acceptance testing, and that makes my life easier. Thanks very much. So I do have to say, if you think this sounds cool, come and work with us on it. It's amazing. It's great fun. Are there any questions? You, sir. Mike.
My name is Marek. I just have two questions for you. The first one is, I don't know the problems you guys have about Angular, but it seems like you have pretty pretty kind of defined set of requirements. So do you have from actually writing acceptance tests before you write the code, or?
Yes.
Okay.
Yeah. So so different teams do slightly different things. Most teams write the criteria before they write the code, because it's just so much easier to edit the criteria than it is to edit the code. And by the time you've got to the point of having implemented something, it's kind of almost too late to change it, or it's too painful to change it. If you can do it at the criteria stage, you're going to save yourself a lot of hassle. In our team, what we try and do is write the criteria and then write the test, and have that test fail, and then write unit tests. So we try to do it in a test-first way.
So do you guys actually work with some projects where you don't have defined set of criteria, where you're actually doing a lot of R&D?
Yeah, certainly we do have R&D projects that are doing things in a slightly more exploratory way, and we have legacy projects that don't have so many acceptance criteria around them.
So talking about R&D ones, do you still write a test?
Are there any labs guys here? No. So you have to talk to them. It's much more open-ended. So it's much more about, so in an R&D context, what you're trying to do is reduce technology risk. Here's a crazy product idea, can we build it? In the majority of the projects we run, it's much more about product risk. So we're pretty sure we can build web applications, and we're pretty sure we can build mobile applications. How should we build it? What should we build? What's the right thing for the customer? What's going to be the experience they're looking for? And in that situation, that's when acceptance criteria kind of really come into their own, because it's, the programmer can go away and build something. That's not the difficult bit. The difficult bit is working out what's the right thing to build.
Right. The second question. I can't remember how you call those. Acceptance objects?
Page objects.
Page objects. So I think it was the last slide before the pattern section. When I know that you kind of mixing callback promises, which it will be possible to actually pass the don't callback into your.
No.
No. Why is that?
I don't really know. I tried that. That was the first thing I tried as well.
So will be possible to, let's say, the get method?
There is. So what I can tell you is there's a notify object on try assertions that will actually call the done callback in a way that works. When you just pass done to then, it blows up for some reason. I think it's to do with the argument.
No, actually not talking about,
okay.
I'm talking about the get method, let's say on the road itself.
Hello.
Yeah, so
Yeah,
you could do
yeah.
that, but then that tightly couples your page object to Cucumber. So we've avoided doing that because we still run some Jasmine tests, and we reuse page objects between Jasmine and Cucumber.
Good.
Yeah.
Thank you very much.
So there you go.
Okay.
Got there in the end. Next question.
Okay. I just got home from work about 10 minutes ago. Okay, you can say left message to you, bro.
So the question is, I've got code to handle the resolving of the promise, but not the rejection of the promise. Yeah, it's just example code. We would handle that definitely. So one of the things that, so this done callback that you get is actually both a function and an object, and there is a .fail method on that. You can call that in the rejection case. Yeah, I should have put that in an example. That's a good point. One of the nice things about if we do get proper handling of promises in the next version of Cucumber is it will just handle that transparently. So any rejection of a promise will result in a failed step. I don't know. Future. I think they scheduled it for June. So yeah, it's not done yet. Okay, next question. Peter.
I'll talk loudly. Okay. You've got obviously mobile apps and web apps.
Yeah.
Do you use web technology to write your mobile apps, or are they?
Yeah. Yeah. So that's the project that I work on, and it's an Angular app running inside Cucumber.
Okay. And so my main question was, in that case, do you have separate
that goes really
mobile, the main web apps, and do you have some kind of reuse going through?
So that's a really interesting point. At the moment, we only have a suite that runs against the mobile app. But one of the kind of promises of this approach of splitting your feature files and your step definitions into two things is you might be able to use different step definitions with the same criteria. So if your acceptance criteria work in both a mobile and a desktop context, you might be able to have two implementations that sort of abstract away the details of that. That, I think, is an interesting idea. I haven't seen it work in practice, but we've certainly talked about it. And we've talked about it in the context of running some acceptance criteria in different sort of parts of the application. So actually, maybe some acceptance criteria work both on a front-end context and on a back-end context. Let's actually run them against some of the back-end services and implement so our back-end is C#. Maybe we could implement some C# step definitions that talk to the back-end, or some hybrid ones that talk to both the front-end and the back-end at the same time. So yeah, that's a really interesting idea.
Sorry, and if you're using Protractor, are you running it against emulations of devices or directly on devices?
So the talk I gave 2 weeks ago was about testing an Appium. So the question was, are we testing on real devices or emulators? We're testing on real devices. We're using Appium behind Protractor. It actually works pretty well. Appium it's called. There is another meetup where I have some slides on Appium testing with Protractor, and it's pretty straightforward stuff. So I'll share those with this meetup as well, so you guys can take a look. But it's basically an implementation of WebDriver that drives real devices, and it's very straightforward to get the same API. So we were originally testing in a browser. We shrunk the window down and made it sort of look a bit more like a mobile, but didn't really kind of cut it. And then we used Appium and actually ported the same tests to run against real devices. And it took us about a week. It was a really quick process. Oh, more questions? At the back.
So, with you're saying that you're automating the browser that is mocking the API.
Yeah.
So, how do you handle API changes, for example?
Yeah. So there's a pull. So we have a library that implements our whole mock infrastructure, and it reads JSON files and builds different scenarios. So we are actually able to. We have a query string parameter that will pick a scenario. So we have a big list of them, and one of them will be like, I'm a user who's been locked out of their account. Another one will be, I'm a user who's already got a loan. I'm a user who doesn't have a loan. And we can use our query string parameter to pick the one we want for a particular test. So when we do a browser.get, we'll actually say browser.get login page scenario equals account logs. And then that sort of slots in a particular set of mocks, which we know will result in the specific behavior in the application. Our app is really driven by the back end, so all the kind of possible actions that the front end can display are all determined by the API responses. There is a pull request against this library that we use for loading mock data, which basically says, I want to be able to change my mock data as the test is progressing. So, I might get the state of the account object, do some interactions, and then get the state of the account object again. I want it to be different now. I've resisted merging that pull request because I think it will result in a lot of complexity in your test. So we sort of organize mocks into these particular scenarios, but then once you're in a scenario, you're kind of locked in, the data is pretty much static. And that's served us pretty well so far. It's not perfect, but it's kind of gotten us by. The question is, could we not sort of stub the back end in a richer way? Yes, we could definitely do that. There's a question about how much time do we want to invest in stubbing the back end versus trying to keep our code simple on the front end. And when we've had that kind of discussion, we've tried to keep the front end code simple so that we can test it with a simple set of API responses. It's a pattern that's kind of, it works if you start from a greenfield application. If you're retrofitting an existing app that's doing kind of slightly unpredictable things, less predictable things to the API, then it's more difficult. You may need a kind of simulator.
And part of this question was, when you make changes, how do you keep on top of it?
Yes. So we generate our mocks as an output, some of the tests from the backend code. So the backend code is a REST API. We have a set of tests there called journey tests, which run through a lot of the different journey flows. And as those are running, they generate mock data, serialize it into JSON, and we then install that as a Bower module in our build process. So anytime we do a new build, there's an up-to-date version of the mocks that works with the latest version of the backend. And that's very cool. We're super proud of that piece of code.
I've got a question regarding mock data you mentioned. The issue I find a lot of times is when I run a test like, when I log in using the correct password 3 times, then my account should be locked. And the next time you go to run that test again, that account is still locked. So do you still end up with a quick reset when you have it?
So we have endless debates about the best way to test a particular piece of functionality. That's one that I would argue potentially is better tested on the back end. So the back end is going to return some response the first 3 times, and then it's going to be a different response the 3rd time. In the front end, we'll test what behavior, what we will do, what rendering you'll get in each of the 2 different scenarios. So if there are a number of login attempts left, and if there are no login attempts left, if your account is now logged. And then we let the back end do the kind of state change stuff. And even in the back end, we have the sort of API tier, and we probably wouldn't integration test that with the whole set of services. We'd actually probably say, as long as the API is sending and receiving the right inputs, then that's behaving correctly as well. And that's enabled us to be have a test suite that is a bit more robust, runs a bit more quickly. Yeah, a question?
I just want to know, as I see this done, the jump step, correct?
Yes.
But in the first step, we create our new login page, right? And we call get, which navigates there.
Yes.
And then, we jump to when we create login page again, which whatever is logged. So
yes.
should we navigate again by again before we log in?
No, so there's no state in the test. There is state in the browser. So what we're doing by executing these tests is creating a queue of commands that will be sent to a WebDriver that will either drive a web browser or will drive a mobile device. So when we do the first step, that get command will be executed, the page will load, and then when this step comes to execute, the browser will still be sat there with that page in. So the browser is the piece of state. Yeah, definitely. Yeah, so one of the things you could potentially do is have some shared context. So you could actually create a login page object in the first step, reuse it in the second step, reuse it in the third step. That's not necessarily a bad pattern, but it means you can't reuse your steps in arbitrary places in the application because it needs to have been paired with the relevant other step. So I've tried to avoid that. Okay. You can do one more and then.
Okay, sure. I'm pretty sure you talked about it, but I just can't remember. But if we do have shared some definition, like an ID that can be carried over from one definition.
The state between the different, yeah.
Did you say that the word context is available?
Yeah, there are objects in Cucumber that allow you to do that kind of.
And they will be passed into functions similar to those.
I don't know how you actually access them, but if you check the docs, I'm sure it's pretty straightforward. Any more questions? Oh, sorry, I'm not entirely sure who I was pointing at, but I remember you were first, so maybe you and then you.
Yeah, sorry, I have a question. So I'm experimenting with projects at the moment, and I keep getting the problem that when I normally write my project test to Chrome, but when I'm on Chrome on mobile device or Firefox, it keeps saying in clicking happen.
Yes.
How can I, it's like anybody says code to this language?
So you can answer this question, I think.
I don't think I mean, that's...
Oh no, that was Phantom, wasn't it, that we had to...
Yeah, that's like the most common problem ever. Ignore synchronization stuff, page animation, asynchronous requests.
Yeah. So Protractor is fragile to what WebDriver is doing under the hood. Ignore synchronization is an important thing. You need to make sure that. So yeah, so your object needs to be, the object you're trying to click needs to be visible. It needs to not be moving. It needs to actually exist on the page. So we've built a bunch of helpers that will wait for that kind of stuff to happen. We actually turned off animations in the version of the app that we acceptance test. I wasn't super happy about that, but it's improved stability and the performance of the app, of the test suite as well. And I know that the Angular team are doing the same thing. So I can't answer that question because we don't scroll. We don't have any content that scrolls. We actually, because we're a mobile app, which is like. So yeah, it needs to be visible in the viewport.
So one of the things with WebDriver 2.0 and the previous London version is that they changed the implementation to a real native implementation. So if there's something above it, that means you can't click down underneath. It won't be able to click it, and nothing moving on the top, or if it's not visible on the screen, it won't be able to do it. So 2.0 is a real native implementation. This happened 3 years ago. But WebDriver 1.0 is the difference.
Yeah, so it means your test is a better recreation of what the user experience will be. Okay, so now you get to. So Cucumber.js doesn't really have a great selection of reporters. I have on my desktop some code for, I'm writing a JUnit reporter at the moment. We want to plug that into our Jenkins instance so we can get nice report graphs and see what tests are failing on repeatedly. It is also lacking an HTML reporter, so I'm intending to, that was my copious free time, but if anyone else wants to write an HTML reporter, please tweet the link so I can use it as well. Formatters for Cucumber are pretty straightforward things to build, so you could implement any functionality that you need. And they're tested with proper acceptance tests as well, so to write a feature for your formatter.
So I would like that during the development it could be tricky to know the application and do you know that there is a tool that you can use your given criteria to move the browser to the state
or the developer will do.
So that's where we use mock data. We'll jump into a page, we'll inject some data, and we expect the page to come up with whatever state we need it to be in. So if I'm on a dashboard, it would know, have the user's profile data. It would have any other kind of bits of information that you need to render into models into your Angular view. So we inject that stuff through the controller into the page, basically.
So during development, controlling the page, you don't click and set the page for the state.
When we're developing, we do a mixture of those, but for writing tests, we always use mock data. Cool. So maybe a couple more questions. Any more questions? Ori.
Hi there.
Hi, Paul.
So I was wondering about how, like, the other end of it. So the beauty of this is that you can share this language across your product with your product owners and more business-facing people. What are your experiences with that and introducing them to this? And do they kind of then think that they're essentially coding and run away, or do they kind of think, oh, this is actually quite a nice way for us to write our acceptance criteria? Like, I feel like there might be a bit of a bridge there, and if there are any kind of things you come across to help that.
So different teams, I think we've had different experiences. I think it's pretty clear that there's value in agreeing what it is we're going to build in a really unambiguous way up front, and everybody kind of gets on board with that. I think initially, given when then was perceived as extra work. So I'm going to have to do loads of work in order to write all this stuff. I know the product spec, right? It's super easy. Why don't we just have a conversation about it? But actually, after you've had a few kind of, oh, hang on, we've done this story completely wrong moments, the benefit of putting those criteria together ahead of time and in an unambiguous way becomes pretty obvious. Does that answer your question?
Okay, last question.
Last question. Gentleman here.
Going back to the question, when you talk about using mocks instead of extracting validating DOM to set state, do you have another set of tests to make sure that the actual state imposed by the DOM is what your mocks do?
Yeah, so as I said, we do a combination of two things. One, we generate the mock data so that we can be sure that it matches the contract exposed by the API at any given time. Secondly, we have a suite of integration tests, and those are just end-to-end tests right now, and they run through the 5 or 6 core interactions, core flows of our application. So we have those are kind of like final seal of quality. So the goal is to catch stuff at the earliest stage possible. If we can catch it in a unit test, great. If we can catch it in an acceptance test, okay. If we have to do an integration test to catch it, well, at least we caught it. So if we then find an integration test bug, then the goal is how do we write a better acceptance test and then a better unit test to catch that earlier. Okay, thanks very much, guys. That's all we have time for. If you have any more questions, come and talk to me now. What's the ID?